Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Shawn Laatsch, the director at the Versant Power Astronomy Center at the University of Maine. I've had the good fortune of knowing Shawn for years. He's been an integral partner to the Maine Science Festival, and it was a delight to talk to him about his science journey and love of outer space. His enthusiasm for public understanding of astronomy is readily apparent, and I honestly think we could have talked for hours about how space exploration continues to delight and surprise, as well as all the ways Maine is contributing to that. I hope you enjoy our conversation as much as I did. Shawn, welcome to the Maine Science Podcast. It is a delight to have you here. If I have it right, you've been in Maine for about 6 or 7 years, and I think we met shortly after you got here. You've been a critical part of the Maine Science Festival for many years, and think a super interesting backstory. I bring up that in particular, your undergraduate degree is International Economics and Business Administration, which is a long way away from astronomy. So I thought you could tell us a little bit about how you got into your love of space science and then how you ended up here in Maine.
Sure. Well, I grew up in rural Wisconsin, in Wausau, which is a town roughly about the size of Bangor, maybe slightly larger, but not by much. And we lived a little bit outside of town, about 5 miles out. So I had good dark skies growing up. And I remember my grandfather showing me the Big Dipper, and that kind of sparked my interest when I was real little. That was the only constellation he knew, but didn't know that one, and pointed me in that direction. And then in second grade, I visited our local planetarium at the high school. And a lot of folks don't think planetariums in high schools, but it's actually very common. About 80% of the planetariums in the United States are in high schools or universities like ours here in Maine. But anyway, I visited it as a second grader, and the teacher operating it asked if anyone wanted to help. I raised my hand, and he happened to call on me, and he put me behind the console. He let me bring down the lights and turn up the stars, and I was absolutely hooked. After that, I started reading every book I could find on astronomy. And when I got back there as a high school student, I started teasing him for the first week after school every day. And finally, he said, "Yep, you're serious about this." So he let me start helping him. And my sophomore year, I was put in charge of public programs, which is when Halley's Comet was coming by, and just continued from there, and then did it through college. I put myself through my undergraduate degree and beyond. So that's kind of how I got my start. I felt like I had a really lucky to have that opportunity. What was really great, back in August, I actually got to catch up with my mentor again. He's just turned 80, but he's still doing stuff part-time at a planetarium down in Florida in his quote-unquote semi-retirement.
This is the same gentleman who called on you when you were 7?
Yes. Oh, I got to know him, and he became a really good friend, and I've stayed in touch with him all these years. And like I said, he retired from the Wausau School District, and he moved to Florida. But then he started working part-time at a planetarium in Pensacola down there, and continues to do so till this day. He teaches one class a semester at a university there, and works in the planetarium. So that's kind of cool.
So you didn't dive into space science until your master's degree. I'm curious if that was because of access, because you didn't know it was possible, because you weren't sure it was something more than planetariums, right? And kind of public science events are not a typical route for a science degree, right? Like you get a science degree and you go in a lab usually, right? So this idea that you would get a degree focused on science and not go deep into a lab, is that how you kind of finally circled back to space science?
Yeah, I think about the time I was going to college, NASA had some cutbacks. There were some different things going on, and I'd had an economics class, and I really enjoyed it, and I always liked international culture. So I sort of ended up going that route because the astronomy field didn't look really great, particularly for folks who didn't want to be a research astronomer. And I knew early on that that was not my bailiwick. I really was interested in sharing the astronomy and communicating it and more of that thing. But I took astronomy courses along the way, even when I was doing my undergrad. Any spare time I had, I took astronomy classes at the university and kept up my interest and worked in the planetarium there. Like I said, that's how I put myself through my undergraduate degree, was working at the planetarium at the university. And when I got out, the business field was in a recession. Sounds familiar. But I had, basically 4 years of high school, 4 years of college working in the planetarium. And I happened to be offered a planetarium job. So I jumped at it, got back into what I really loved. And, a couple of years in, I'm like, yeah, I need to go back and quote unquote legitimize myself. So I went back and did my master's in Earth and Space Sciences with a teaching focus, because again, that's really what I wanted to do, was share the night sky with people of all ages. So basically, I've been working in planetariums since 1984. which is a long, long time. But I love it. And I had a unique opportunity. And I try to give that back with students here. It's one of the reasons I love the fact that I had this project in the Netherlands I was on for 2 years prior to coming here to Maine. And coming back to Maine after that project finished, coming back to the States and having this opportunity here in Maine has been wonderful because it takes me back to planetariums like my roots, about the size that I had in high school and college, and getting to work with students, which I really love doing, and sharing that and giving them those same opportunities. And one of them is actually went off to become a planetarium director in California now, one of my first students I had from when I arrived here.
It's pretty neat to see that family tree kind of continue. So I think one of the things that I found falling into the world of public science events is that that you adore science, but you don't necessarily want to do the research part. You want to do the communication and the other part. And I have found there's a significant number of people literally all around the world who fit in that slot, and they all try to find each other out. So I'm curious if your interest in international studies and other cultures has helped you as you have fostered relationships throughout the planetarium world and the astronomy world so that you can have great ideas or just better connections with things.
Yeah, I've been very lucky in that regard too. So after I graduated with my degree in economics and I continued to work in the planetarium, a couple of years later, one of my college mentor or instructor at the planetarium there nominated me for this position with the International Planetarium Society as a treasurer, because he's like, it's an international organization. You have a degree in international economics. And it so happened I got elected and I served in that position for 18 years. Then later went on to be president of the organization for a while. But that was really wonderful because it gave me an opportunity to work with planetariums around the globe. It gave me opportunities to travel and meet people. Of course, there are planetarium regional organizations and conferences here in the US that I go to as well. But IPS has played a huge role and really, expanded, I think, my horizons, if you will, in a variety of ways, because folks do things differently in different countries. And it's very interesting. I mentioned 80% of planetariums here in the United States are in their K-12 or university settings. There's only about 20% that are big, museum class ones, like the Haydens and Griffiths and things like that. But in other countries, the reverse is often true. Usually, most other countries, the bulk are in our museum settings, often publicly funded, so they don't have to struggle as much as the ones here in the US. But some of them do too. That's not always the case. And interestingly enough, I remember one of my first trips to Russia back in 2000, and it was surprising there that about 85 to 90% of the planetarium directors I met when I was in Russia were males. There's one or two really, really big ones like Moscow and St. Petersburg had male directors, but all the other ones primarily had female directors, which was very interesting. So you see these different things, around the globe, and it was kind of interesting, and having a chance to travel and meet in different places too opens up your eyes to a whole variety of things. I still remember learning that Britain had a national astronomy curriculum and wishing to myself, oh, if that could only be true here in the US, instead of having the States constantly fighting over, this is what you teach a third grader versus this is what you teach a second grader, which is whatever, because people move around nowadays. And it's so much more efficient if you had a standardized curriculum across the board. So lots of interesting things you learn when you travel. That's one other piece of advice I always give my students is, as soon as you can, get out there and travel, meet with other people, exchange those ideas. You're going to find that there are different ways of doing things, and you can learn from each of those. You adopt the ones that work well for you, and and some might not, and that's fine too, but it's always interesting to see.
I think that's great advice. I think one of the best things you can do is, even within our own countries, to travel to different parts, different regions, because the Southwest, the first time I went there, I was just gobsmacked at where's the green? There's no green anywhere here. And then, but there's a whole other kind of beauty going on there. So I think right now in particular is one of the most exciting times to be connected in any way, shape, or form with space and looking towards the stars. I am certainly old enough that when I was growing up, like many people, I think I wanted to be an astronaut. It was shortly after the heyday of the Apollo missions. It was just a big deal. It was, you look up in the sky and you think, I want to go there. And then you add in all the sci-fi movies that came out that made space travel appear as if it was just around the corner.
Easy, jump in a Falcon and go.
Exactly. Thank you. But it is actually, I think, true that right now, I don't want to say we're in a golden age, because I think that actually makes it sound dated. I think we're in a really interesting age of exploration and rethinking what we have off of this planet that is interesting, in combination with things like the upcoming solar eclipse in 2024. I know that you and I have talked separately about, I don't know if you use this phrase or not, but eclipse chasers, right? So people
Yes.
who are going for eclipse. So I would welcome giving you this opportunity to kind of explain what you think of the exciting stuff that's happening with space, whether it's the fact that there's private companies involved, which I would imagine you have different takes on depending on perspective. I certainly do. I have different opinions about that, almost depending on the day. The stuff that's coming out of the James Webb Telescope, which is just extraordinary, the Artemis mission, and then the eclipse that's coming up. Hopefully, if we do it right, people are going to realize what a big deal this is. So I am now giving you the floor, Shawn, to have at it for like these really exciting things that are going on.
It is a really great time. I think there's just so much going on, and you almost have to pick and choose what thing you're going to follow to some extent, because everything from the recent DART mission where they impacted this asteroid to change its trajectory, which is looking at planetary defense, which is very important for our planet as a whole. Most people don't realize, that we have more craters than the moon, but Earth's a bigger target, but so happens a lot of them are underwater. Plants and trees grow over the top of them. But we still get hit. In 2013, we had one in Russia, Chelyabinsk, that, blew up and it actually injured people, blew up in the atmosphere and, shattered glass and people got injured by it. So these things still hit. We don't want to go the way of the dinosaurs. So having that DART mission, that double asteroid redirect test, all the acronyms that NASA has, but, it was really important. James Webb, I can't tell you, that's just been so incredible to see the imagery coming down. And it's really, it's hard to say revolutionizing, but I think it really will. One of the things that struck me is every image that you look at from James Webb, pretty much, with the exception of one or two, which have been of our solar system, almost every other image has galaxies in it. Even if they weren't looking for galaxies, there's galaxies there. It's just tremendous, the amount of galaxies this thing is seeing. And it's really going to help us understand, I think, that early universe, the first stars, the first galaxies, and some of that early evolution and formation of the universe in a totally different way. So I do think it's revolutionary. And it is really cool to see all the stuff coming back from that telescope. And there's so much more to come. I mean, it's been able to look at individual planetary atmospheres and detect water in some of them and a couple of them so far. And I mean, that's going to move us forward in the search for life and just the whole understanding of a variety of processes that we weren't able to really witness before. So it's really exciting. Solar eclipses, what can I tell you there? They are one of the most spectacular things in all of nature that you will ever see. If you have not witnessed totality, partial eclipses are lovely, but they're not it. Solar eclipses are it. It's kind of the difference between, running a foot race and winning some type of marathon, in terms of totality. It is super incredible. The temperature changes. The sky is not completely dark, but silvery and an odd thing that you really can't pick up in any type of camera. It's just so special. I've been lucky enough to witness 4 totalities during my lifetime, traveling for some of them. My favorite one was probably the one in 2006. I took my wife and we did an eclipse trip, and we ended up seeing the eclipse from Libya back before things had changed there. And it was wonderful because we were on this cruise with all these folks talking about eclipses. My wife's a psychologist and she's like, I'm sure it'll be cool, but I don't think it's going to be all that, And the day of, we got out and there was ground clouds, which never happens in Libya. It's a desert and you don't expect any of that. So it was kind of scary, in terms of that side of things. But when the eclipse started, and totality started, I looked over at my wife and tears were streaming down her face. I'm like, what's wrong? What's wrong? She's like, it's so beautiful. And it's one of these things. I love sharing that story because it just shows how something that she had been hearing all this hype about it, and it was better than even the hype. And she told me after that, anytime you want to go on an eclipse trip, I'm with you. So we did in 2017. We went out west, of course, to see one. It's so spectacular. And really, pictures just don't do it justice because you feel the air temperature drop. Birds and animals pay attention and get quiet. Seeing it in a group is the most special thing because just the reactions of people. But it does get dark enough where you can see some of the brighter planets during the daytime and some of the brighter stars. But again, it's not total darkness. It's more twilighty. But the color of the sky is really silvery, feathery. There's just a weirdness to it that's hard to describe. And each one is different because the shape of the corona, which you can only see during totality, is different depending on if you're at a solar min or a max, where you are in the cycle. Sometimes it's more bipolar. Sometimes it's very uniform, but really, really spectacular. Everyone needs to see at least one during their lifetime. April 8th of 2024 here in Maine, we hope. I know April's not the best month to be looking for this in Maine, but we definitely are going to be trying. It's not total in Bangor or Orono. You need to travel west, and you do need to get to that center line because there's, like I said, the difference between 99% and totality is huge. It really is. So we're going to be one of the state suppliers, if you will, or state source for solar eclipse glasses. We already have 5,000 in stock because last time we couldn't keep them in stock. So we've already got 5,000. I'm guessing we'll probably get more. We'll have a dress rehearsal in October of next year. There'll be a partial solar eclipse so that'll get people a chance to get their mind around it. And we're starting to work on some teacher workshops with the Maine math and science teachers group as well. So we'll be doing some of those coming up. So yeah, it's really spectacular. We do have a lunar eclipse coming up in November, a sunrise eclipse. That'll be the last time we'll see totality in terms of a lunar eclipse. And they're different. Of course, you don't need anything special to see them, just your eyes. But that one is going to be taking place at sunrise, but it'll be the last one until 2025. So urge folks to get out and take a look at that too.
Can you explain the difference between a solar eclipse and a lunar eclipse?
Eclipses happen when one thing is causing a shadow on the surface of something else. So in the case of a total solar eclipse, you're at new moon. The moon is between the sun and the earth and appears to block out the sun. And the moon is casting a shadow here on earth. You need special glasses to look at it because you're looking at the sun. You should never look at the sun without special protection because it can do permanent damage to your eyes. So you do need to be careful. That being said, there are plenty of safe ways to view it, whether it's solar eclipse glasses or pinhole projection or things like that. A lunar eclipse can only happen at full moon, and that's when the moon passes through the Earth's shadow. And the moon will turn sort of a deep reddish brown coppery color. Basically, light is being refracted through our atmosphere and bent onto the surface of the moon. And you're getting some of those colors there. And depending on how much stuff is in the atmosphere, like if there's volcanic ash or a lot of pollution, that will vary the color of that lunar eclipse. You don't need anything special to see it, just your eyes, binoculars can help you a little bit with that as well. Now, with solar eclipses, they are very short-lived. Totality is very short-lived. It's usually anywhere from a few seconds to a few minutes. The longest one during our lifetime was in 93. That was about 7.5 minutes long. That's the longest they can ever be. And didn't get to see that one. I only got to see a partial phase of that because I was a college student back at the time. But this one that's coming up, we'll have about 3.5 minutes of totality for that one. Now, lunar eclipses, totality can last over an hour, and the whole eclipse itself can be for several hours long. With a solar eclipse, it's a couple hours long, but again, totality is very quick. But lunar eclipses, totality can last over an hour because it's passing through Earth shadow. And the other nice thing is with a lunar eclipse, you see it from half of the Earth. The entire nighttime side of the Earth gets to see a lunar eclipse. With a solar eclipse, you have to be within that 100-mile wide strip to see it in totality. If you're on either side, you only see it as a partial.
So when you said the center line for Maine in the solar eclipse, that's what you meant. There's a 100-mile strip, basically, where totality will take place. And if I remember correctly, Millinocket is kind of dead smack in the middle of that?
Yeah, Millinocket, Rangeley. Yeah, so basically you're heading west, northwest of here and west of here to get it totality. That center line is going to pass all the way down through Texas and Mexico. And at the risk of being a little bit blasphemous, if you really want to more ensure your chances of seeing this eclipse, go to Texas. I won't be doing that, but the weather prospects there are much better. But you can see they already have out this road atlas for the eclipse as well, where you can find all the cities on it. And if you just look up the Great Eclipse of 2024, you're going to see, of course, the whole path for the United States, and can even look up by state where the center line is going to be. One other key thing for that is if you decide you're going to view the eclipse here in Maine, just be cognizant of the fact that people try to travel on eclipse day. When we were out for the 2017 one out west between Idaho and Montana, it took us 45 minutes in the morning to get to the site. Coming back, it took us 6 hours to get back to our hotel because of traffic. I've been told by some that I was actually lucky in that sense, that it only took 6 hours. So if you can go someplace and stay overnight, we're going to view the eclipse, probably a good idea. Actually, myself and a couple folks from Dark Sky Maine, which is a preservation group here to preserve the skies, we've already reached out to the Maine Department of Transportation and the Maine Tourism Office to talk a little bit about this, to try to get them thinking about this and hopefully making some plans and helping people with this. And Maine doesn't have some of the big highways like they have out west, other than 95 and a lot of the places where the eclipse is, it's actually going to be on small back roads. So it will probably take even longer if you have to go and come back. So if you can get someplace where you can stay for a day, that's probably a better choice.
I'm going to make you switch gears a little bit and ask you something totally not related to your work, but well, it is. I have always been struck by how much Maine has a connection with space from the perspective of astronauts on a per capita basis. We're kind of punching over our weight. We have really interesting companies. I know Blue Shift has gotten a lot of buzz in the last couple of years, but there's been a lot of other companies and people who are deeply ingrained in space exploration in different ways. One of my favorite companies in Maine, it's FMI, Fiber Materials Incorporated. And, they kind of grew out of textile industry expertise. But what they do is they make the composite high heat shields. So like part of what they build is on Mars, existing on Mars. It's why the rover landed, is because of a Maine company. Really great stuff. So I'm curious, as someone who has lived in all different parts of the States and overseas, is it parochial for me to think that Maine really does have this huge impact? Or is it just kind of being aware of it in ways that I haven't been in other ways?
I think Maine does have a very large impact given the size of the state and particularly the population of the state. So Maine is very involved. It was one of the things I was pleasantly surprised to find out when I got here in the state, because I know the University of Maine before I got here, and I'd actually visited the old planetarium, through conferences years ago. But I really didn't have an idea of how well Maine was connected until I got here. And, even finding out here at UMaine, we have the HIAD project, which is, a landing payload packages on Mars and other places. And we have the wireless sensing network that has a whole lunar habitat module. And right now we're involved in CubeSats. It's amazing what is happening here just at the university. But then, when you expand to companies like Blue Shift and a number of the others out there, it's really amazing to see. Even TI, the James Webb Space Telescope has chips manufactured here in Maine by, Texas Instruments, which is really amazing. So, there's lots of things that are going on here in the state. In fact, one of the things I'm involved is with the Maine Space Grant Consortium here in Maine. Every state has a space grant. They recently have been pushing and just got approval from the legislative body for, of course, creating a spaceport. And people might think, a spaceport in Maine, what are you going to do with that? Well, we're perfectly positioned for launching these CubeSats, these really tiny satellites. And when you have a company like Blue Shift that also is making biofuels, which is making this environmentally as responsible as possible, it's a really good pairing. But we're really poised for these little tiny satellites that are basically would fit in your pocket, if you will, almost to launch and do a variety of science missions. And there's some high school students that have even got involved in some of these, and college students. So it's a great way for folks to do so and get students interested in space. So Maine has, and then of course, Jessica Meir, we're all keeping our fingers crossed. She's slated to be on one of the Artemis missions. I'm keeping my fingers crossed it's for number 3, which is the first one to land on the moon. I'd like to see her be not only the first woman, but the first Mainer to walk on the moon, which would be really cool. And I think would really be a wonderful inspiration to our young women and girls here in the state, because that's the thing. Space is for everyone and astronomy is for everyone. I'm always trying to say, that we need to spend more time there and encouraging young women and girls to go into this, because it's definitely for them. So, and Jessica Meir, I think, is a perfect example of that. Caribou, Maine, and is flown on board ISS and will be flying on a future Artemis mission.
So I think one of the other things that you have there at UMaine in your planetarium that a lot of people don't quite realize is the telescope. So I want to actually throw this at you. It's not your backyard telescope. This is a totally different thing. So I think it would be helpful for people to know that you have this and what you do with it on a regular basis.
Sure. So we have 2 observatories out back, if you will, behind the planetarium. On Friday nights after our regular public programs, we open up the historic Alvin Clark telescope for public viewing whenever it's clear, so people can come and take a look. That telescope was installed here on campus in 1901. It's been moved 3 times. It was a premier research instrument in the day, and it still provides incredible views, particularly of planets and star clusters, things like that. So definitely come and take a look through it if you want to look through a telescope. Now, our other telescope, the one that's actually in the dome behind our building, because the Clark is in a roll-off roof, just a flat roof that rolls back. But the other one, the Jordan Observatory, if you will, that telescope is a 20-inch plane wave. It was the largest research telescope in the state when I got here back in 2016. It's now the second because around 2018, Colby put in a 28-inch version of that telescope. But we do have some partnerships and collaboration, so it's a very much a collaborative thing, not a competition thing, I always like to tell folks. But that is a research telescope. And basically, we have a number of undergrad and grad students who use that to do astronomy research projects. We've had everything from supernova searches to right now, one of our grad students is working on exoplanets, to some folks who worked on characterization of asteroids. You don't look through that telescope because most modern astronomy telescopes, you actually don't stick your eye up to the eyepiece anymore. You have an electronic detector on board. In our case, we had a CCD camera. We're in the process of changing that out because our camera was installed originally with the telescope and is now having some failing pixels. So we have a new CMOS camera that is supposed to arrive in November. Based on what we've been told. It's been pushed back a little bit, supply chain things, but we're supposed to be getting that in November and then getting it installed and then resuming some of the research projects here at the University of Maine. But undergrads can get involved with that. Grad students, of course, use it. We've even had a couple high school students apply for time. One of them a while back actually won a full scholarship as a result of the science fair and ended up getting a full scholarship to UMaine based on her project a couple of years back. So yeah, that telescope does research here at the university. And Dr. Batuski is sort of the person who tell folks if you want to do research with a telescope, you got to get it approved by him. And then you talk to us about getting you access and getting you trained on how to do things at the telescope itself. We can operate it remotely, which is kind of cool too. So you don't have to sit there and freeze in the middle of winter or boil in the middle of summer. So in that way, it's like some of the modern research telescopes I worked at when I was out in Hawaii with the Mauna Kea observatories.
You said the telescope from 1901 has been moved 3 times. How do you move a telescope like that?
Very carefully.
I knew you were going to say that.
Yeah.
It's a fragile piece of equipment.
It's not super fragile as long as you don't drop it, of course, things like that. But we actually worked with a gentleman who is an expert in historic telescopes and has worked at several observatories. And we contracted him to come in and help with this last move in particular. But when it was originally installed on campus early in the day, then it got moved over by the union. It was behind the union for a while when I first got here. In fact, it was one of the first assignments the dean gave me is, hey, we need to get this telescope moved. And, we want someone who can oversee that process. And that was an interesting one. But yeah, we contracted with a gentleman out of New Mexico who knows historic telescopes. Because of the way it was set up there, it had to be dismantled and very carefully moved and then reinstalled. So it was a little bit of work, but yeah, you're taking the telescope out of the mount, packing it up in some things so it doesn't get bounced around much, and then you put it on a truck and move it. And this telescope is one that could fit in the back of a pickup truck. It's again from 1901, it's 8 inches in diameter. It's about 6.5, 7 feet long. So we very gently boxed it up, put it in the back, moved it over here. Actually, initially moved it into storage because we were in the middle of waiting for the observatory to be completed here. But then as soon as it was, started the reinstallation and recalibration and all of that.
So is one of the reasons you move it because light pollution affects it? I remember, I think it was in Providence when we lived there. There's an old observatory that back when it was built was on the outskirts of town and now is deep in the middle of Providence, right? So it's beautiful and it's kind of neat to look at, but it's probably not as effective as a telescope. So is that one of the reasons this one has been moved as much?
That really was the primary reason. So I know at one point it got moved, I think, because of the site where it originally was. They were building a library. So that was one reason it got moved to where the union was. Then the union grew up around it. And then the light pollution at the union was just really bad for it. And the building, at least by the time I got here, the dome that it was in had also fallen into some disrepair and things like that. So we can control our back parking lot lights, at least the ones immediately behind our building, to a red mode, which helps with viewing. We still have the lights off to the side, which are standard and unfortunately recently been upgraded to 5000K, which is making me want to pull the hair out of my head. But we still have somewhat reasonable skies from behind the planetarium to do things, which is helpful. But yeah, it is one of those things that primarily, most of the time when you build an observatory, it stays there unless you have a problem. And, and if it's small one, it's easier to move. But some of the big ones, you're never going to move those. So a lot of places that have major observatories like Hawaii, like Arizona, like Chile, and other places have lighting ordinances that don't allow lights above a certain height, that don't allow lights above a certain color temperature, things of that nature. Make sure that lights are shielded towards the ground so that they're not just lighting up the underbellies of planes, things like that. So that lighting is an issue. And it's an issue here, unfortunately, it's an issue in downtown Bangor. I mean, I lived there a few years now, and, in the last couple of years, they've changed out to all LEDs. And LEDs are great for the amount of energy they consume. But people often think, oh, we need to put in the same wattage to get the brightness, and you don't. And also the color temperature is really important. So ideally, lighting should be 2,700 to 3,000 Kelvin. It should never go above 4,000. 4,000 and 5,000 are blue and white lights like daylight, which is bad for humans' health. It's bad for animals. It's bad for the environment in numerous ways. It actually increases insect populations, something that folks don't think about. Anyway, there's a whole host of things, but we do. It's one of those things that in Bangor and Orono, we do have some issues with lighting. So hopefully over time, we'll get folks to think about that more, but it's tough. There's a group working on that, but I know over time.
One last question for you. And I have to say, in all the time we've known each other, it has never occurred to me to ask you this until now. Have you yourself ever wanted to go into space?
When I was a kid, yes. When I got to meet and talk with astronauts about the experience of being in space, not yet. When it gets to a case where we can just walk on board the Falcon and go, yes. Or, beam me up, Scotty, and go, yes. But as space travel currently is, I think I'm good. Astronauts talk about the space sickness they experience. For typically about 80% of them do or better for the first several days. Your blood redistributes. If you notice, their faces always look puffy. Most of them say that it feels when you're in space like you have a constant head cold because of that redistribution of blood through your system. Everything is more complicated. Everything from going to the restroom to most things that we take for granted are just more difficult. So I don't think I'm ready for that. I love exploring space from the ground, looking at things from the ground, but I don't think I'm ready to do the travel part until it gets a little bit more advanced, shall we say, which I don't know if that'll happen during my lifetime. That might be unrealistic too. It is the thing of science fiction. And I leave it to the folks who are really good at it, like Jessica Meir and some of the others.
That's how I feel too. I think it's really important, though, to point out, like you said, that you love space and you can explore it from here. I think the pictures from the web in particular have been, I thought the pictures from Hubble were amazing, especially after all the problems that Hubble had, right? And then they had to do this amazing fix of the satellite, but it's not even comparable. I mean, it's like going from black and white to color.
Yeah, it's a different wavelength, so it does look at things differently, and it does give us a different perspective. And that's, like I tell folks, you go to a doctor, they use all this different technology because if they could just look at you, they're not necessarily going to know what's wrong. But if you have a CAT scan, an X-ray, an ultrasound, all those things, modern astronomy is that way. You use lots of different wavelengths. Speaking of that, though, I will say this. Maine has some of the darkest skies on the eastern seaboard. And I really encourage folks to get out and look up at your night sky. Even if you are in Bangor or Orono, you still have a lot better skies than they have in Boston or Chicago or things like that. You still have dark skies here in Maine. And if you can get out just a little ways, you can get some really dark skies. In fact, Katahdin Woods and Waters is an international dark sky preserve, and it's absolutely stunning. There's an event there a couple of weeks ago. Milky Way was just breathtaking. So get out and enjoy our skies here in Maine and do your best to preserve them because it is a resource. And it's not just about seeing the sky, but it also affects our health, birds and animals, and other things too. So it's something well worth preserving and taking care of, just like our whole environment is.
That is a great note to end on. I never get tired of hearing about all the wonderful things that we have here in Maine, and a reminder that we really do have extraordinary skies, even not very far away from our big cities, is a really good reminder. As much as it's hard sometimes to be outside in the cold, I personally have found that the winter skies are extraordinary. I don't know what it is. I don't know if it's a cold thing or if it's just that I'm noticing it because it's earlier than in the summer when it's late. But
Probably
that has been, it's been really interesting. It's one of the things that I, at some point, inevitably every year, either in January or February, we're outside looking literally from our driveway. We don't even throw a coat on. And then when all of a sudden we realize how cold we are, but it happens every year. We're struck by something. This has been a delight. I really appreciate this. I love the enthusiasm with which you are talking about astronomy. It's almost enough to remind me that I wanted to do it briefly before I realized how hard the math was and it wasn't my thing. So it's a nice reminder that there's other parts of astronomy that you can do that don't involve hardcore research and just as much fun and interesting. So thank you so much for this and for the work you're doing.
Thank you.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is hosted by me, Kate Dickerson. This episode was edited and produced by Scott Loiselle. We received financial support from Central Maine Power, production support from Miranda Bouchard, and social media support from Next Media. The Discover Maine theme was composed and performed by Nick Parker.